this on our website. So take it away, Dr. Haas.
Right. Thanks so much. And it's good to be back with all of you. So I'm an infectious diseases physician. I'm affiliated at Denver Health. I'm also a member of the Colorado Vaccine Equity Task Force. And so we'll briefly talk about COVID vaccines in children and also do an update on boosters. Next slide, please. So I always like to start just making sure we're all on the same page about COVID-19. I think, for most people, this is a review because we've been living this for the past almost, I guess it feels like almost 2 years, really, since March. It'll be March of 2022. So, but just to kind of level set, so COVID-19 is caused by a virus called SARS-CoV-2. And up to 40% of people may have no symptoms at all, feel totally fine, not realize that they are sick. And then on the other end of the spectrum, some people get very, very sick and unfortunately have passed away from COVID-19. We do know now that some folks are at more risk for complications related to COVID-19. And so, for example, pregnant women. So that was actually something that wasn't quite clear early in the pandemic, but now is very clear that pregnant women and pregnant people are more likely to have complications from COVID-19 disease and also are at higher risk for losing their pregnancy. And so that's another reason that vaccination is so important, particularly for pregnant women. So that's something that I think was evolving that we didn't quite understand or appreciate early on in the pandemic. So COVID-19, the other thing I think that's also important to keep in mind is that even though some folks are at higher risk for complications, we still unfortunately do see people who are totally healthy who end up getting hospitalized and having severe complications from COVID-19. And so even younger folks in their 20s and 30s. And so vaccination still remains a really important way to protect ourselves against complications from COVID-19 and reduce our risk of becoming infected. It's a lot safer than actually acquiring what a lot of folks will talk about as natural immunity. Next slide, please. And so, I think there is a lot of information about how the vaccines work, but I thought I would review this as well. One of the first things to note is that all of the vaccines for COVID-19 are only constructed of parts of the virus. There are other vaccines for other diseases where they actually use the whole bacteria or the whole virus, but not for COVID-19. It's only a small component of the virus itself. And so the small component that's in the vaccine is the code or the genetic material, if you will, for the spike protein. And the spike protein is how COVID-19 will attach to our cells and enter into our cells and start to make copies of itself. And so if our immune system can learn to recognize that spike protein and block it or kind of, surround it, if you will, then that will prevent the virus from entering into our cells and then we don't get sick. Or it may not completely block all of the viruses that we're exposed to, but block enough of them such that we don't get really sick from COVID-19. And so, the vaccines, what they do is they only make that spike protein, and then that allows us allows our immune system to learn to recognize it. And then that will allow us to be protected. And so that's kind of so these schematics here are actually schematics of what proteins look like, what antibodies truly do look like, and how they can surround a virus and then block it so that it can't go anywhere and protect us from getting sick. I guess yeah, go ahead. One more thing to note is, so I've gotten questions about, well, do these vaccines, do they incorporate into our DNA? Is there any concern about that? And that's not the case at all. Even for the vaccines that we're using for children. So it's messenger RNA, and messenger RNA is the code that actually never enters the nucleus where our genetic material is located in a cell. It stays outside. And it's actually quite fragile. and falls apart in about 6 to 8 hours. And there's, we've kind of talked a little bit about reasons for anyone to be vaccinated. I think there's reasons for our children to be vaccinated in particular, that don't necessarily apply to adults, or overlap with adults. So we know that vaccines are safe, they're effective. We also know that children are as likely to be infected with SARS-CoV-2. And I think that's something that also has evolved. I think early in the pandemic, because we weren't seeing many children testing positive for COVID-19, it seemed as though they had some kind of inherent resistance or they weren't as likely to get infected. Now we know that likely what we were seeing is that children often have more mild symptoms. And so they don't present as being sick. And so then, we as parents, we don't take our child to get tested because they seem okay. I can give an example of this. This happened to one of my colleagues. So she has 2 kids. One child is at home with a nanny. So she has an infant daughter, and then has an older son who's 3 and goes to daycare. And her infant daughter developed a fever. And so she was the first person to develop a fever in the family. And so they took her to be tested. She tested positive for COVID-19. Her 3-year-old son never tested positive for COVID-19. So we think that by the time he potentially had passed it to his sister, he had already cleared it, because it was several days after they kind of walked things backwards. And then she got infected because she's breastfeeding and was around her infant daughter. And so I think a lot of this was sort of happening early on in the pandemic. We didn't really appreciate that. So I think that's an important thing to recognize, is that our kids are as likely as we are to get infected, but they will handle it better than we will. Now, that being said, kids can still develop severe disease. And, it's just at a lower proportion than you might see in adults, and children in particular who have other medical conditions. So children who may need prednisone or need an oral medicine to control their asthma. Children who have or living with diabetes. So there's a list of conditions that children might have that could also put them at higher risk for complications. And so even though children as a whole may do okay with COVID-19, as I mentioned, they can still get hospitalized. And as of October of 2021, there have been over 8,300 children hospitalized in the United States with COVID-19. And we've had over 100 deaths at this point. So this slide's a bit out of date, among children aged 5 to 11 from COVID-19. So, and then when you look at comparing the proportion of children hospitalized or who have passed away from COVID-19 compared to flu or potentially hepatitis A, so two other vaccine preventable diseases, COVID is actually, so the risk of hospitalization and death of COVID compared to flu is about the same. COVID might be a little bit more compared to flu, and is actually higher, much higher than hepatitis A or other vaccine preventable diseases. So I think it's also important to put that into context, in terms of the risk of COVID-19 to our kids. Next slide, please. I think the other reason, this is a really big reason for at least for the reason that I vaccinated my kids, is that it can allow them to safely stay in school, can keep our schools open, and can allow them to safely engage with their friends, play sports, and really gain more from social emotional development than they could when a lot of our children were engaging in remote learning. And I think that's a really important thing. I mean, I still, reflect back on my 10-year-old who told me that she'll never take in-person learning for granted and really struggled with online learning. And then my youngest child, who's 6, was 5 last year, wouldn't do online learning at all. That was just a lost year for her. She couldn't do it. So I think these are some of the impact of this, the pandemic on our kids related to school and learning and social emotional development. I think are things that we really need, that are incredibly important to focus on, and vaccinating our kids and also ourselves can help mitigate some of those impacts and keep our kids in school. Next slide, please. So then what about the vaccines themselves and the dosing? So they intentionally, so Pfizer intentionally chose to look at a lower dose. So dosing for vaccines in general is really based on the anticipated immune response, which actually is in some ways related to the age of a person. So there is this link there. And so they're not weight-based dosing at all. It really is, so that's pretty standard for other vaccines, that it's more tied to age and then other comorbidities. And so they intentionally chose this lower dose, thinking that they could still see a really strong response, immune response in younger children, and then hopefully spare some of the side effects, including some of the very rare severe side effects of inflammation in the heart. So they picked a dose that's 1/3 of the adult dose. So it's 10 micrograms. And in their trial, which was almost 1,500 kids, they saw that it was 91% effective in preventing infection. And there weren't any hospitalizations and no deaths, no evidence of inflammation in the heart in any of the children who got the vaccine. So the vaccines, not only were they reviewed by a safety committee that was independent of the study, that's called the DSMB. It's a safety monitoring board that's linked to the study, but independent. So they're not participating in the study. They reviewed it, and then the FDA reviews the trial, as well as CDC, and then ACIP. So it's really 4 independent, panels of experts that aren't linked to each other, aren't linked to the company that review the side effects. So it's a pretty robust review. The common side effects that they saw, so it's more in the vaccine arm, which is what we would expect, and 1.1% in the placebo arm. There weren't any severe adverse events that they could tie directly to the vaccine. And one thing to note about trials is that anything serious that happens to a child or a trial participant, they have to report. So for example, one of the severe adverse events that was reported was that a child swallowed a penny. So that happens. So should those you have children, you understand that can happen despite direct supervision. And so that clearly isn't linked to the vaccine, but it had to be reported. Another serious side effect was one child accidentally had a fracture of their arm, and so that wasn't related to the vaccine. My children were vaccinated, and I can tell you that I considered this a relatively serious side effect. They both complained that they couldn't do their laundry the day after they got their first dose. So I thought that was pretty serious, but my husband did not. So, and then what was interesting is that they couldn't do their laundry, but yet they were fine to sort of play and jump around later. So they didn't get away with that with the second dose. They did have sore arms, and with the second dose, my oldest daughter had a headache. So, all of the side effects that I have listed here. So tiredness, headache, muscle pain, chills, fever, pain and redness and swelling, that can happen. But all of those side effects are things that can be managed in a child and go away after about a day or so. Next slide, please. So as I mentioned, there weren't any serious, there were a few serious side effects, as I mentioned. Those were the ones, where the child swallowed a penny, there was a fracture, and they didn't see any cases of myocarditis. Just to kind of level set, with adults, the risk of myocarditis, so that's the heart inflammation, is about 1 in 25,000 with the vaccine in adults. Now, one thing that people don't realize is that you can still see heart inflammation in folks who get COVID-19 disease. And that's much, much higher. So that's 1 out of 667 people who get COVID-19 disease. And so taking the vaccine for adults will reduce the risk of inflammation in the heart. And that's, I think, particularly important for, teenagers who might be engaging in sports. There's certainly a growing information about how there might be some residual impact on the heart in younger teenagers who get COVID-19 disease. And so vaccination can prevent that from happening. Blood clots are only really seen with the Johnson & Johnson and are incredibly rare. The other thing that's been reported are deaths after people have gotten vaccinated. One thing to note is that it's hard to, so they have to report all deaths after a vaccine. So if I take my vaccine and I'm in a car accident, then that gets reported. And so me being in a car accident wouldn't, necessarily be a side effect from the vaccine. And so that, so that being said, they've noted that 1 out of about 50,000 people have died after taking the vaccine among adults. I haven't seen that for kids at all. And then just for context, the odds of being struck by lightning is about 1 out of 12,000. So your odds of dying from the vaccine are much, much lower than being struck by lightning. I think that includes Colorado too, but so next slide, please. So this is just also for some additional context in terms of how many people have been vaccinated in the United States. So just over 200 million people who've been vaccinated in the United States, and then about 54 million people who've gotten boosters. And so that amounts to about 72% of the US population. And so these data I pulled, I think on the 10th. So these numbers are already outdated, just for some additional context. Next slide, please. So I do think it's important to talk to your child or the child that you're caring for about vaccination. I was really surprised that I think it was just a lot of the hype. My 6-year-old who will, takes a flu vaccine like a champ. She comes up and she leans her arm in, and, in contrast to her older sister who has a lot of anxiety, she was nervous. And so I was surprised by that. So we had a conversation about it, talked about it. And I think it's just, she's heard a lot of people, probably heard me talk about side effects from the COVID vaccine. And so kids, kids are kids, they hear a lot, they listen to our conversations. And so I think it's important to talk to your kid about that. And and really, all caregivers or parents, that your child the best in terms of how to share information and talk with your child, and how you would frame it, and being honest and open with them about the side effects. And then depending on your child's needs, being ready to comfort them in a way that makes sense for them, talking to your pediatrician, and then making that appointment for the second dose. And so this is a picture of Dr. Rhonda Achelanu, who's comforting her son. Who's being very brave and getting his first dose of the COVID-19 vaccine. Next slide, please. So now we'll go ahead and talk about boosters. Next slide. So some of the key considerations for boosters is that we now have a good appreciation of the impact after the first 2 doses, that our immune systems, I guess one way to frame it is that they start to forget a little bit. And the antibody titers, or the protection that we have, goes down a little bit or wanes over time for preventing infections. What we have noted, even in the face of Omicron, is that protection against severe disease and hospitalization still remains relatively high. And so what I mean by that is that with Delta, for example, protection against hospitalization and dying from COVID-19 is still in the 90s. The most recent data about Omicron is that after 2 doses, the impact on preventing hospitalization is probably about 70%. So it's definitely decreased. And then with Omicron, the data from both Pfizer and Moderna. So with Pfizer, it looks like it's about the first 2 doses are about 30% protective against Omicron. And then with Moderna, and I just heard this today, it's about 50 times less effective after the first 2 doses. The other important context to note is that most vaccines don't actually completely prevent infection. Most vaccines are designed to prevent severe complications. So some of the other things to think about, so some of you may have heard of Shingrix. So that is a vaccine that's recommended in people aged 50 and older to prevent complications related to shingles. And so shingles is a really painful rash, if you're not familiar, that comes from the virus that causes chickenpox. And so even though we might have chickenpox or have been when we're younger, we can still, it can manifest later on in life as this really painful rash. And so Shingrix prevents that. Other vaccines, like vaccine to prevent pneumonia, doesn't prevent us from acquiring the bacteria that causes pneumonia, but prevents complications like developing a bloodstream infection and having to go in the hospital. So with the COVID vaccines, in some ways, we got really lucky because they prevented infections so well with the earlier variants. And so now, what we're seeing in some ways is what we see with other infections, where it doesn't completely prevent infection, it reduces that risk, but still offers us high protection against hospitalizations and deaths. That being said, we do know that that protection goes down over time. And so because of those two sort of two facts, that, people can get more infections. And then, they're now with Omicron in particular, there's a slight decrease in protection against hospitalizations. That forms the rationale behind recommending a booster. Next slide, please. Some of the other key considerations that were also factored into some of the recommendations are looking at people at risk for severe disease, and including folks that may have barriers to receiving care if the infection is acquired. And that's one of the many reasons why in Colorado, we were early to say we want everyone above the age of 18 and older to have access to a booster before even the CDC came out with those recommendations. There have been longstanding and continued concerns about vaccine equity. So as I mentioned, kind of before we started the talk, is that, the number of people in South Africa, for example, who have access to the vaccine or have been vaccinated is around 30–40%. There are still some countries that are in like the 10% or less range. And yet we're rolling out boosters across the United States. And certainly Israel has rolled out boosters to its entire population, and other higher income, well-resourced countries. And the danger in that approach is that when you have pockets of places that are under-vaccinated, that is where variants can emerge. And so it really is incredibly important to be very intentional about ensuring that everyone has access to even their first 2 doses. And that's true also for here in the United States and across Denver County. There's still some disparities. We talked about the waning immunity and then the early data on Omicron. So we do know that now with both the Pfizer booster and the Moderna booster, so they've released that information that both boosters can increase the protection high enough that a person is protected against infection with Omicron, almost to the level of the protection that we saw with Delta and with the other with the first 2 doses, and that protection can be sustained. And so, getting the booster is one of the key ways that people can reduce their risk of getting Omicron, and then also reduce the risk of other variants as well. Next slide, please. And so this is a slide actually from CDPHE. So this is Colorado data, where they looked at the risk of getting COVID among people who were unvaccinated, people who were fully vaccinated but didn't have the booster, and then people who were fully vaccinated with the booster. And so people who were unvaccinated, so that's the green line here. And then the blue line is people who were fully vaccinated without the booster. And then I guess it's periwinkle or purple line here is people who have been fully vaccinated with the booster. And so what's very clear is that people who are unvaccinated, the proportion of people who are getting COVID is actually going up. Whereas people who've gotten their booster as of November, if anything, it's flat or slightly decreased compared to even people who've had the first 2 doses. And so when you look at the overall, people who've received boosters are 2.4 times less likely to develop COVID-19 than people who are vaccinated, and 9.7 times, so almost 10 times less likely to have COVID-19 than someone who's unvaccinated. So pretty powerful data that how boosters protect us here in Colorado. Next slide, please. And so this is even more of a dramatic difference in terms of risk of hospitalization. And so what we see here is that people, so unvaccinated individuals, in terms of their being hospitalized, is dramatically higher than the number of people who are hospitalized who've been fully vaccinated with 2 doses or who've gotten their booster. And so people who've gotten their booster are 3.3 times less likely to be hospitalized than people who've had the first 2 doses, and almost 50 times less likely to be hospitalized than people who've never been vaccinated. And so these are, of course, before the emergence of Omicron, but based on the information that was released from Pfizer and Moderna, I would anticipate we would see a fairly similar reduced risk of hospitalization with the boosters. Next slide, please. So right now, everyone age 16 and older can get a booster, and that's across the United States. And so this is actually a slide from CDC that kind of breaks down the detail a bit more, and then by the type of vaccine. One thing to note is that the booster for Moderna is half of the usual vaccine dose. And so they chose that intentionally to also try to reduce the risk of side effects and after getting the booster dose with Moderna. And so it's still highly effective. And so if someone chooses to get Moderna, it is important to let the place where you're getting vaccinated know or sign up for the booster dose because of the dose difference. Unless someone is immunocompromised. If someone's immunocompromised, then they would get the full amount of the 3rd dose. So for example, I care for people with HIV. So someone who's living with HIV would get, if they chose Moderna, they would have use the 100 microgram dose for their 3rd dose. It is safe to mix vaccines. And so somebody started out with Pfizer and they want to switch to Moderna, they can do that. If someone started out with Johnson & Johnson and they would like to get their booster with a messenger RNA vaccine, that's definitely supported. And there's some early data to suggest that mixing of Johnson & Johnson with either Moderna or Pfizer may even boost immunity even higher than just choosing to mix either Pfizer or Moderna or sticking with the same series. That being said, I don't know that we're at the point where we think those data are robust enough that would be preferred. I think, I would still message to folks like, take the dose that you can get scheduled for because vaccine appointments are still pretty tight. Unless, of course, someone has a very specific preference or reason to, that they would prefer Moderna over Pfizer because that I have seen, some folks just, for whatever reason will prefer one product or over another. And that's okay. Next slide, please. So you can get a booster really in many retail pharmacies across the city and county. There are also mobile clinics that a person can sign up for. You can also sign up through Denver Health's MyChart, and then UC Health also has places where you can sign up as well. Next slide, please. So there's a few remaining questions. I put this slide together in some ways like, well, the original slide was before Omicron, so then I had to tack on some stuff about Omicron. So, you know, one of my 10-year-old, like the first question out of her mouth was, am I going to need to get a booster? I was really surprised about that. But so we don't know if children, you know, or teenagers or, you know, children under the age of 16 will need a booster. My guess is that they will. Just because we are seeing waning immunity even in the 16 to 17-year-old age group, which is why we extended the booster recommendation down to the age of 16. But I think we need to wait for the data. And I think the data will come because Israel has been at least vaccinating in their community down to age 12 in terms of offering boosters. So we should, hopefully they will share some of their experience, you know, and so we can learn from that. And so when I did this slide also, so that was right before today. So this is the problem with COVID. I need to like put a date on everything because I submitted these slides and then I heard today that they'd done the studies with Moderna and did have the press release. So we do know that now that Moderna does protect against Omicron and can bring the level of antibodies back up to you know, a very high level of protection. You know, as of tonight, I hadn't heard anything about Johnson & Johnson. So, but for all I know, there's been another press release about that, but so more to come. But I do know that they are looking at Johnson & Johnson as well. And in particular, the combination of Johnson & Johnson with with either Pfizer or Moderna. And so we should know really soon about Johnson & Johnson and how it might protect against Omicron. And with that, I'll go to my last slide. And thank you very, very much.